So, hello students, how are you all? I hope you are doing absolutely fine. In our previous lecture, we have discussed about some of the components that is attached to the electrical circuits, and we have seen the color coding of the wires we have. Now, in today's lecture, we are going to discuss about the electrical safety of any device. So, electrical safety is a very essential process that has to be done to prevent from the shock. So, our next term is about the electric safety. So, for our electrical safety, we have to use many type of the connections, but basically what we will do the earthing. Secondly, we will do the earthing of that particular appliances we are using. Third, we will use the fuse, and fourth, we will use the MCB, that is called the miniature circuit breaker. So, electrical safety can be accomplished or applied by using these four processes. So, the first process in this sequence we have about the earthing. Secondly, earthing of an appliance. Thirdly, we will use a fuse, and fourth, we will use the MCB. MCB means miniature circuit breaker. So, these are the processes we will use for our electrical safety: earthing of an appliances, fuse, and the MCB. Now, let's discuss all these categories one by one. So, firstly, we are discussing about the earthing. So, in this category, we have our first description about the earthing. Now, for the earthing purpose, what you have to do, you have to take an copper rod of a specified thickness, and you have to just dig a hole about 2 to 3 meter in front of or in nearby your kilowatt meter. Kilowatt hour meter is a meter that is situated in your homes. That is the line which is giving the main supply to the all the appliances that you have used in your homes. So, near the kilowatt hour meter, you will install, or you will take a copper rod that has to be inserted in a hole that is digged 2 to 3 meter in the earth, and after that you have to install a copper plates. The thickness of the copper plates is approximately 50 by 50 in the base of the earth that you have do the connections there. Now, after that, what you have to do, you have to take a mixture of charcoal and sand, and you have to place it near the copper plates. So, time to time, when you supply the water to the system, what will happen? There will be the conduction between the plates and the wire take place. So, this is how the earthing will be done in case of the electrical safety. So, firstly, what you will do? Firstly, let's see the diagram here. So, this is our main line, that is our kilowatt hour meter. This is a wire that is coming from kilowatt hour meter, and what you have to do, this pink color that I have drawn, this is our copper rod of the specified length. This is our copper rod. We have installed a copper rod of the specified length here. This is our copper rod. Now, this is what we have taken. This is our copper plates of the dimension 50 by 50. So, this is actually our copper rod that is installed in the ground, and this copper rod, this is not a copper rod, this is a copper plate. Copper plate that is having a dimension 50 by 50. And here you have taken a mixture of charcoal and sand. So what we have taken here? A mixture of charcoal and sand. Now, this is how the earthing of a component is done. What you have to do, you have to make your connection near the kilowatt hour meter. This is your main supply here. Here we have taken a copper rod that is of the specified length which is installed in the ground. And what you have done, you have just dig a hole that is 2 to 3 meter near the kilowatt hour meter. So, we have just dig a hole here. We have done a digging of hole here. Dig a hole up to 2 to 3 meter. It means in that 2 to 3 meter digging of the hole, you have just put a copper wire that we have taken. Now, after taking a copper wire, in the base of the copper wire, you have to take a copper plate. This is our copper plate, which is of the dimension 50 centimeter into 50 centimeter that has to be installed in the base of the ground. Now, this connection has to be specified with a mixture of charcoal and sand. Charcoal and sand are mixed and kept in a copper plates or the electrical rod where this connection is established. Now, when time to time, when water is supplied, you can see that when water is supplied, there will be the conduction between this plate and this rod. And if there will be the conduction, we can see that this device is actually working. Now, in case of the electrical devices, how earthing is used? Basically, you can see that when you are using a large amount of devices in your homes, whether you are using washing machine, refrigerator, air conditioner or many electronic devices you are using. So sometimes what will happen, you can see that excessive amount of current will be passed through the circuit. So in this case, there will be some hazards take place and there will be a cause of electrical shock or fire maybe take place. So for this purpose, what will happen, if there will be the connection with the earth, then the excess amount of the current will be passed through this earth wire. That's why we have connected this earth wire with the kilowatt hour meter line nearby it. So most of the current will pass through the ground only. So that's why copper is a good conductor of electricity. We are using the copper plates that is installed in the ground. So this is how the earthing basically works. Now, our second thing is about the earthing of a particular appliances. Now, how the earthing of an appliances work here. So the second point is about earthing of an appliance. You have used or you are using a lot of devices in your homes, like it may be electronic toaster, electronic geyser, electronic kettle and many of the electronic devices you are using in your homes. So you have seen that the handles of these devices or the body of these devices are made up of the insulating material, and sometimes this body is kept in the metallic case. This is generally you have observed. So what will happen, in this metallic case, a connection is established in such a way that when you touch that insulation part, you will not get any electric shock. It means the earthing of a particular wire in this case has been done. Because when you are using, suppose you are using electronic toaster at your home. So what will happen in this case, if the insulation is not provided and the body will not have a metallic casing, what will happen? The live wire will come in contact with the earth wire. When there will be the contact between both of them, or live wire and come in the contact with the metallic body part. So there will be the conduction of current and there may be the chances of getting the electrical shock there. But by earthing the particular appliances, you can reduce the effect of the current, and we can protect ourselves by just earthing the particular component. So let's see the diagrammatic representation that how the earthing of a particular appliances should be done. So now let's see how the earthing of a particular appliances work here. So here I have taken a metallic case. This is our metallic case. This is what? This is the machine element we have here. So this is how the particular appliances used at our home can be earthing can be done. So how it is possible? You can suppose you are using the electric toaster, electric geyser, electrical oven at your home. Now you have seen that the body that is made up of the particular type of the electronic component you are using, it is made up of the insulated part. So insulation is basically provided so you do not get any shock in case of any hazard. So in this case, actually we are handling with the live wire. So the connection of the particular part of the component is done in such a way that the particular component is painted here. You have seen that painting on the particular component is done, either it may be of the silver color you have seen. So painting is usually done, so there will be the insulation, or there will be no live wire, and the neutral wire that is used in the circuit will not come in contact with each other. Because live wire, when comes in the contact with the metallic body part, we will get the electric shock here. You can also see that we have used a fuse here. So fuse is a device which particularly melts when there is a exceed current pass through the circuit. So this is how you can done the earthing of a particular metallic appliances you have used at your home. Sometimes you have also seen that when the paint is removed from the particular electrical component, if you are using it and you are handling it, you will get a shock. Why you are getting a shock? Because that wire will come in contact with the metallic body part. Because the paint is removed, the insulation between these two components are entirely removed from the surface. So this is how the earthing of appliances that we are using in our daily life has been done. So this is about the earthing of an appliances. Now our next two parts which are used for the electrical safety is about the fuse and MCB. So how fuse and MCB works, let's see here. So the third electrical device is fuse. Now, what is fuse? Fuse is actually a piece of wire. We can say that it is a piece of the wire that is made up of the basically alloys. Why we are using alloys? Because alloys have a very zero resistivity, very low resistivity alloys have. So we are using it to make the fuse wire. So what is fuse? So fuse is an electric device which is used in the circuit. So whenever current exceeds the limiting value, it will melt in the circuit. So we have seen that fuse generally melt in the circuit and is connected with the main supply with the circuit at our home. So I can say that it is a safety device. It is a safety device in the form of small piece of wire. It will be in the small piece of the wire, and this wire is actually made up of the alloy. And it is made up of the alloy. And the alloy which is generally used for making the wire that is of the fuse wire is lead and tin. So the alloy you are basically used will constitute lead and tin. So lead and tin are generally used for making the fuse wire, but one thing you have to remember that fuse wire will have a very low value of the resistivity, so current may pass through it. It should have very low resistivity. And the alloys we are using here, that you have seen that we have used lead and tin. Lead and tin are used here, and it is a percentage of about 37% and 63% we have. So this is the composition of the alloy of the fuse wire we are using here. It should have a very low resistivity so that when current exceeds its particular value, it melts, because fuse is made in such a way that it will have a very low value of the resistivity and low value of the melting point, that it can melt very easily. So this is how fuse work. Now, next term is about MCB, and the MCB stands for miniature circuit breaker. So just copy this from here so we can discuss our next topic, that is about the MCB we have. So the fourth device is about MCB, and it is the miniature circuit breaker. The fourth part is about MCB, and it stands for miniature circuit breaker. Now, what is miniature circuit breaker? Nowadays, a fuse is replaced by a switch. MCB is actually a switch that is known as the miniature circuit breaker. It means whenever there is a large amount of current flowing in the circuit, it means current exceeds its prescribed value, then most of the current will pass through this switch only. So, in the modern times, instead of using fuse, we are using MCB switches. So, MCBs are used in place of switches, and it is a device when current exceeds the maximum value its prescribed or maximum value most of the current pass through MCB. So this is about the MCB we have, and nowadays instead of using fuse wires or any alloy, we are using MCB in the circuits. So these are the two last criteria which we are using for electrical safety. So these are the two processes we are using for electrical safety. First, we have learnt about the earthing. Secondly, we have seen the earthing of a particular appliances at our home. Third is fuse, and fourth is miniature circuit breaker. So you have seen here that how electrical safety is essential for us. So this is the last topic of our chapter. So we have completed our chapter of physics, that is electricity. So this lecture is over today. We will start our new chapter, that is about the magnetic effect of electric current, in our next lecture. Thank you so much and have a nice day.